So the first format is the R format, which is, so again the instruction is 32 bits wide, and we divide this 32-bit instruction into these many segments, or we commonly call it field. Okay, so first of all, the first 7 bits from right always represents the opcode, which tells the computer what operation it has to perform. It's a shift left operation, add operation, sub operation, or whatever. Okay. Then RD corresponds to the destination register. RS1 corresponds to source register 1, and RS2 corresponds to source register 2, second source register. We have 2 additional fields, func3 and func7, that are used for additional functional code, like what function processor is required to perform. Okay. So R format is referred to is used for those instructions which has all registers as operands, like add instructions, add x10, x11, x12, for example. All are registers operands, no constant data, no immediate data. Okay. So we have the destination registers and 2 source registers. So let's take an example of what you write as a high-level language code, like this: A equals B plus C, and we have studied that how it is translated into the RISC-V assembly code to something like this: add x9, let's say x9 corresponds to A, x20 corresponds to B, and x21 corresponds to C. So this instruction is converted into machine language with the help of a piece of software which we call assembler, into machine language like this. So opcode, the add has a specific standard opcode, which is value 51. Okay. So whenever computer or the processor hardware reads the first 7-bit, and if it is 51, then it means that it has to perform add operation. Okay. Add operation among what contents? So here is the source register 1, which corresponds to x20, source register 2, x21. So these are just the name of the registers. These are not the actual contents. Okay. So recall that we had x20, x21. So what it will do, while reading the instruction, it will identify that it has to perform addition operation. It has to grab the contents of x20 and x21, add them together, and put the results back in register x9. Okay. So this is how processor will read the instruction. And this instruction, which the values are written in decimal, it is represented in binary. So this is the final binary instruction. And this is what you call it a machine code. So you can imagine, like, you have studied how to write a high-level language code and how it is actually executed on the processor at the very deep level. Isn't it fascinating that what you have been studying, what you have been using programming, and how it is translated by a compiler to RISC-V code and then into machine language code. And again, this is the string of bits, simply bits. While looking at this string, you cannot identify what it is, but the computer knows. Okay. And again, writing and reading the string in this format, binary string in this format, is not really convenient. So that's why we have learned another way of writing these binary formats into hex format. Yes?
Is 51 the address of operation?
It's not the address. I would say it's a code. So whenever computer reads these 7 bits as a value 51, it will determine that it has to perform the addition operation. Now, how that addition operation is executed, that we will come later. Okay. Any question here? So yeah, so you will learn how to decode this instruction in this course also, because you might be given this instruction, long instruction, and you should be able to read what is the value in this field, and you will be able to determine what operation is this instruction is going to perform. Okay. We will do an activity also today. All right, so any instruction in this format, like have 3 register, RD, RS1, and RS2, are all covered with the R format instruction. You have like RD here, RS1 and RS2. Any question? Okay, let's do a quick knowledge check. So we have the instruction format right in front of us. The number values are mentioned in decimal. Again, the opcode 51 is used for addition as well as subtraction. But how to identify whether it's an addition or subtraction, it is determined with the help of func7 field. So you have the following four options available. Which instruction is it? C. Most of you guys are saying C. Why is it C?
Because it says 32, and then up in the top, that's the binary representation for 32.
32. Yes, the func7 value is 32, which means that this is a subtraction instruction. So we have two options, or three options for subtract instructions. It means that it cannot be B, of course. Now, from these three options, what is the correct one? So we have two source registers, RS1 and RS2. So RS1 is 10, X10, and the RS2 is X9. So X10 and X9. And then we have the destination register X11. So this is how we can determine which instruction this is this format is pointing to. Okay?
Do they always go in order? So the source register 1.
Yeah, so the order for the source register will always be same in R format instructions. Okay? Okay, so let's see this table. So you can see for add, sub, and all the R format instruction, the opcode is same, which is equivalent to 51. The only difference is in func3 and func7 fields. So func3 and func7 field will help us identify which instruction it is. RD and RS1 and RS2 will always vary, but opcode, func3 and func7 together helps us identify which instruction it is. Okay?